Hi guys, this is Mrs. Norris and this is section 5 for chapter 2, geometry. It's called algebraic proof, and we're going to start applying all of these reasoning skills we've been trying to develop. Um, Doing simple algebra problems, but then saying why we know we can do them. Okay? We're going to give reasons, basically, for the things you've been doing the past couple of years in your math classes. So the first thing I want you to do is I want you to get on end grade. You can always create two windows while you watch this video if you're watching on your Chromebook, and create another window simply by taking this tab and dragging it. If you open it, another tab, and drag it, it'll let you make a single window. And then you can minimize it, watch the video over here, and fill in over here as you go. Okay? So once you do that, and you open the Google Doc that's on the nGrade Wiki, you should see this. Now you have a couple of choices here. I've shared this document with you, but you can't edit it until you make a copy. So the first thing you can do is click File, Make a Copy. You'll notice that in the front of the title it says Copy of, and then I typed in your name. I want you to change that, instead of copy of your name, to your name, Mrs. Norris, and then it'll still be labeled as Geometry 2.5. Once you click OK, it'll open that document in a new tab, and now you have editing privileges, so you can literally type in the notes directly right into these boxes and have an electronic copy of your document. You're also welcome to just print the blank document now. I'd rather you didn't rewrite it in your notebook, because then you'd have to rewrite all of this, but it's really up to you. And you're going to fill in these notes as you watch this video. Okay, so you have your handout there, or you have an extra window open on your screen. Either way. The other option you could do is you could play the video on your smartphone or on another computer and be working on your Chromebook filling this in. So we're going to switch gears just a little bit. You have your handout there, and we're going to fill that in a couple of minutes. I want you to take a few minutes and do these 5 algebraic proof problems. I'm going to give you a couple hints about these, but I'm not going to show you the actual answers. We're going to talk about them in class tomorrow. Remember, in algebra, when you're trying to get to the variable, you always do the addition and subtraction first. So you're going to subtract 5 in this one and then divide by 3. I think you can figure out number 2, and number 4 is similar to number 1, but in number 3 you got to remember that we got to get all the t's on one side and all the numbers on the other by adding or subtracting or doing what the opposite is of what's happening in the equation. In number 4, realize that we are dividing by 5. So we need to multiply both sides by 5. Once you do that, you should have n plus 8 equals negative 30. And then you would realize you need to subtract 8. In this one, you're going to realize that you got to get rid of this 20 first. Then you need to get rid of the 2 by dividing it, and then finally adding 5. So hopefully you can do these. Take a few minutes, pause the video, and work these out so you can show me tomorrow. Okay, we're going to talk about proofs today. And yes, this means we are leading into geometric proof. A proof is what uses all of this logic, like I said, we've been trying to develop. It also uses all the definitions we know, like complementary and supplementary angles, postulates, properties, things like the segment addition property and the angle addition property. And we're going to use those to be able to prove that conclusions are true. An important part of writing a proof is that you have to tell me why. We call this justification. Remember, I told you that we're going to put a reason for all of the things we've been doing in our previous math classes. Okay, so back to your chart. You should see this chart. Either you're filling it in electronically or you're filling it in by hand. We're going to start by defining what we call the addition property of equality. The addition property of equality is going to be abbreviated here. So when you are writing the justification on your papers, you're going to use the wording or abbreviation that's here. And you'll notice that this is slightly different from the book. I'm giving you an out here so you don't have to write the whole phrase. You can write this phrase here. And we'll do lots of practice tomorrow. So the addition property of equality says this. If I gave you an algebra problem like this, you would realize that the next step would be to add 5 to both sides. So we say when we add 5 to both sides, our reason or our justification is the addition property of equality. Similarly, if I give you r plus 3 equals negative 2, you can realize that in order to solve for r, we're going to subtract 3 from both sides. When you subtract 3 from both sides of the equal sign, you say subtraction property of equality. In the next example, I'm going to give you the formula for the area of a triangle, and I'm going to realize that in order to get rid of this half, if we wanted to solve for b or h, for example, we would multiply both sides by 2. When you multiply both sides by 2, you're using the multiplication property of equality. And the last one is if I give you 3y equals 15, you can guess what we're going to do here. There's your word. We're going to divide both sides by 3. And when you divide both sides of the equal sign by same number, you say division property of equality. Okay? We're going to use these abbreviations. The next 4 properties are a little bit different than maybe you've heard of, but you use them all the time. The first one is the reflexive property. Think of the reflexive property as the A, or yourself, looking in the mirror and seeing their reflection. This may seem silly to understand why we're defining this, but we will use this quite a bit in proofs. The other thing I want you to notice about the last 5 properties are not only do we have these properties for the equal part, the numbers, we also have them for any congruent geometry parts. So we need to define these for equality and for the congruence. So this A equals A would be an example of the reflexive property of equality. Segment EF congruent to segment EF would be an example of the reflexive property of congruence. Again, this column right here is what you're actually going to write. These are the abbreviations for the properties. Notice we don't have a then for the reflexive property. Basically, you could rewrite this column, but we just have one step for the reflexive property. Okay, the next one is the symmetric property of equality. Symmetric, think about this. I can switch those. I can put B on the left side and A on the right side. We also can define these for the congruence. I didn't make an example for this, but we'll practice enough that we can write symmetric property of congruence. Property number 7 is called the transitive property of equality. Transitive property of equality is also called the law of syllogism. The law of syllogism, if you were to Google it right now, you would find that many people call it the law of transitivity. I want to show you and see if you can see how this matches. Notice that I say if, remember this whole column is if A equals B and B equals C, notice that we have our repeating thing here. Remember when we did it last week, we called it the Q. The Q was the thing that repeats, and then we said in the end that P equaled R. Well, the law of transitivity is similar. We're going to say if A equals B and B equals C, then A equals C. We took our first part and set it equal to our last part. So we're applying the law of transitivity, or the transitive property of equality. Let's look at another example involving the congruent symbol. If I tell you that angle 1 is congruent to angle 2, and that angle 2 is congruent to angle 3, you'll see that it matches the exact pattern of the law of syllogism. We have a repeating angle here. Remember, we called that Q. Then we can say that angle 1 is congruent to the R, we called it, or angle 3. Pay close attention when you're taking your notes that you're using equal sign when appropriate, and you're using congruent sign when appropriate. Remember, it's 2 lines with a little river above there. The substitution property of equality, we're going to use this when we do our FSS. Remember, formula, substitution, solution. So I'm going to go ahead and give you an example. If the base of a triangle is 4 and the height is 6, we now have a reason why we were allowed to write A equals 1/2 times 4 times 6. We simply substituted into the equation. So we call that the substitution property of equality. Sometimes we'll use this for congruence. In this example, we used it for equality. So we're giving an example for the equality version.